Hi guys, Drew Nabb here. Today we're going to cover shocks. So first question, why do you have shocks in the car? What's the purpose? Well, shocks are dampers, and if you didn't have some damping in the car, the second that you hit a bump, the car would bounce continuously until the car stopped, assuming there's no friction in the suspension. So primary purpose of shocks is to make sure that the car doesn't just go full resonant and bounce like a fat lady singing next to a big giant glass full of water. Second purpose for shocks, it gives us the opportunity to tune the transient responses of the car when you're first turning into a corner, when you first stand on the gas, when you first stand on the brakes, and to tune those outside of having to change the final balance or final feel of the car, which you would develop once the car is fully stopping or fully accelerating, or mid-corner developing full lateral. So what forces does your shock actually make? Shocks have compression force, which is force that's created by squishing the shock and making it shorter. Rebound force, which is from extending the damper. And they also have gas force, which is on shocks that have a gas charge. There's actually some force you have to overcome to even move the shock whatsoever. And it acts kind of like a little bit of spring rate and a slight offset force to pick the car up. The rebound and compression forces on dampers are split into high speed and slow speed rebound and compression. Your high speed forces, they generally handle large bumps or like really big sudden jerking motions on the body of the car. Your slow speed rebound and compression, those are what control most of your body movements under braking, acceleration, and roll. So how do shocks work? Well, I have a shock here from my neon torn apart, and in the end here is a piston. And this piston separates the two chambers of the shock, compression and rebound. When the shock pushes down, fluid will have to go past the piston in one direction, and rebound has to go back to the other. Changing shims that block off ports in the piston are how you're able to tune the damper and adjust the forces in the damper under rebound and compression. And some dampers will have a orifice or a small hole in them, which is adjustable by either changing out little jets that unscrew or by turning an adjuster if the shock is an externally adjustable damper. Gas charged shocks. You probably heard the term gas charged shocks before. Some shocks are charged with nitrogen or some other gas, and the purpose of a gas charged shock is to increase the forces that the shock can make without cavitating or foaming the fluid over. This is usually found on most Bilstein shocks are gas charged, and most Konis are not. It depends on the manufacturers whether they believe the shock needs to be gas charged or not, and it's not necessarily guaranteed that a gas charged shock is better than a non-gas charged shock. I would install whatever damper is recommended for your car, and if your damper came gas charged, you need to check it and make sure that it retains its gas charge. To check for gas charge on your damper, you can simply push the damper in, release the damper, and look for the damper to return to its original position. If the damper will not extend all the way on its own, and like this KYB shock, it is actually marked that it is gas charged, then your damper has lost its gas charge and will need to be replaced or serviced. Struts versus shocks. What's the difference? Well, they're both dampers and they both function almost entirely the same way. A shock is only meant to provide forces along its axis. It only handles rebound and compression force. You usually find these in cars in the rear of the car or in cars where they're mounted directly to the control arm. Struts have a shock inside of them, but in the top they also have a bearing in them, and that bearing allows them to handle the side forces or side loads that are present from the suspension. So on a strut car, the upper portion will be attached to the chassis, the lower portion goes right to the suspension, and the suspension pushing on the strut has to transmit through the strut, through the bushing, to the shaft, and then go into the body of the car. It's important to make sure, if you're doing your own inserts, that you verify that the bushing is still in good condition when you replace it. And this is another reason why struts should be replaced more regularly than shocks are often replaced. To verify that your bushing is still in good condition on a shock that you cannot disassemble, look for wear marks in the shaft, and when you notice excessive wear marks on the highly polished shaft, it is time to replace your strut. So how do you tell when it's time to replace your shocks or struts? Well, one obvious thing to look for would be oil leaking out around the shock. Generally this comes out of the top past the shaft seal, and you can see the oil in the boot if you have a boot that protects the shaft seal, or you'll see it right on the side of the damper body. If you see oil coming out of your shock, the next test to do would be to look for dead band. And you do that by removing the shock or the strut from your car, supporting it on a table, and pushing down, let it come up again, and pushing down again quickly. And what you're looking for is a dead band or an area where there's almost no force output the second you change direction. You also want to do this test pretty close to full extension of the damper, because that will let you know if the damper has run out of oil. If the damper's run out of oil and it's non-serviceable, you need to throw it away. If it is serviceable, you need to send it away or service it yourself to add the correct amount of fluid to make sure you don't have a dead band. The last thing you can do, if it's available, and professional teams do this, is put your damper on a shock dyno. Now, a shock dyno will mount the bottom of your strut or shock on a base, and it has an actuator with a load cell in it that measures the forces that your damper will output as it's being stroked and moved at different speeds. Generally, this is only going to be available to somebody that's sending their shocks off to be revalved, but that is an option, and it is one of the reasons why, when you're in doubt, if you have a rebuildable shock, send it to a service center, either a authorized Coney or Bilstein dealer, or somebody else that's recommended as a private shock rebuild facility. So you found out your shocks are dead. You have a couple options to pick from. If your car is a very common model, the easiest option may be to simply buy another damper. If your car is not particularly common, or if you have a damper that you want to place in it that has more damping than is currently available on the market, inserts may be an option. Inserts are generally seen on strut suspensions like this one, and you can find guides online how to install inserts, but the basic premise is that you remove or cut the top ring to release the factory insert. Removing that, you can then place in an insert inside of the strut housing, attach it using whatever fastener mechanism is recommended by the insert manufacturer, and then use all of the strut housing that your car originally came with the new insert. Inserts can be a really good option for cars that have a specialized mount, difficult to find strut assembly, or something that you have actually modified yourself to fit a different spring. Inserts are also generally available in a wider range of valving options than struts alone. And for OEM offered struts, there are actually only a few diameters used. So although the actual strut housing may be different between models of car, the actual components that go inside are generally one of a few sizes. So that's why struts are oftentimes a very economical and practical option to change out dampers on your car. So assume you just want to buy replacement shocks or struts. ChampCar, you're allowed to buy dampers that are within 2x the cost of the OEM dampers as available from a parts store. For most cars, this allows you to use entry-level shocks from Coney, like the non-adjustable versions they have that are orange, and entry-level Bilsteins, B6s and B8s, will fall under the 2x rule for most cars. There are other vendors out there as well, but those two shock manufacturers offer a wide selection of dampers that fit almost every model of car. So there's definitely one out there for you no matter what you drive. So let's say you have a car that's not particularly common, or you want to look into using a shock from another car. There are 3 common shock mount types that apply to most of the cars we see in the ChampCar series and most street cars in general. When looking at shocks, the common fastening types are eyelet shocks like this, stud mount style like this, and the blade style, which you see generally in older muscle cars, where it's a flat piece of steel going through an eyelet style that bolts go on the top. Some shocks will be eyelet on both ends, but you see variations of those 3 styles of mounts used for almost all shocks. For cars with struts, most OEM vehicles have similar geometry and dimensions. You'll find several cars that have the same flange-to-flange width and will exchange with one another. Most struts have the single stud style mount, and actually the stud size is common across several platforms as well. So you have a decent chance of finding a strut from another car that will fit your car. Now, for both struts and shocks though, you need to be concerned with the exposed shaft and the allowable travel of the damper to make sure it'll fit in your car. Now, by exposed shaft, that is supposed to give you an indication of how much travel the damper actually has before it bottoms out. You'll need to match that to your current car or measure and determine how much suspension travel you need to allow your car to not bottom out and have some kind of droop. I would recommend for most Champ cars, if you don't have a starting number, I would leave at least 2 inches of compression travel at the wheel and about 1.5 inches of rebound travel at the wheel. On my Neon, I run maybe a 1/2 inch more than that in each direction just to be safe. The other thing to worry about on both strut cars and shock cars is the overall length of your damper. In this case, it's going to be the measurement from the bolts that locate the knuckle to the top of the damper. If you're using a shock, it's from the bottom eyelet to the top of the damper. This is important to make sure that you don't have an excessive amount of droop travel, which would be the suspension sagging when you pick it up or go over really big bumps, but also to make sure that you have enough droop travel that the car isn't held up and pinned up from its natural static ride height by being pulled by the damper. Again, you want about 1.5 inches of travel downward of the wheel when you jack the car up, and you want at least 2 inches of travel upwards being possible in the car if the springs were removed to allow sufficient suspension travel on track. Something that's commonly overlooked on both struts and shocks is the contributions that the actual mounts make to the forces that the wheel sees. When you're replacing or examining the struts in your car, make sure you look at the strut mounts. These are generally rubber filled. They're prone to cracking, and extra compliance here will reduce your rebound force and your compression force. On a strut car, it can also change your camber compliance. So again, make sure you look these over anytime you're replacing your struts. On shocks, the eyelets, the rubber in the eyelets can go bad. This can get cracked or broken, and just like a strut, this will reduce the compression force and the rebound force that your damper can actually provide to the wheel. Tuning shock forces. So you decided that you think your car needs to have more or less rebound, more or less compression. How do you do it? One of the options available is to buy shocks from a different model car. ChampCar doesn't specify the shocks have to fit your exact model car. So for example, if you're driving a Mustang and you happen to know that a big giant Excursion shock will fit your car, in general, heavier cars have higher levels of damping. That has to do with the vehicle weight being higher, and scaling the shock forces for the vehicle weight will give you a rough idea how much stiffer the shocks will be on a particular car. Another option to look at would be revalving your shocks. Coney, Bilstein, many other shock manufacturers that still fit under the 2X rule offer revalving services where you can ship your shock in and they will return it back to you with whatever shock forces you picked out. If you're unsure what you want, those shock manufacturers can usually give you a rough guideline to get you started. If you provide them information on the springs you run, the inner bars you run, and the rough weight of your vehicle. If you're doing the revalving yourself, another option is to change the oil in the damper. Because shocks work by creating a restriction in the piston that the oil must flow through, the viscosity of the oil will also change the shock forces. Increasing the viscosity of the oil to a thicker oil will increase the shock forces. Decreasing it will decrease the shock forces. For several commercially available shock oils, these numbers are listed. You can get the viscosity numbers off their website. There are also viscosity listed for many generic oils like motor oil or gear oil if you choose to go that route. Another option to change your shock forces is to simply buy a shock that's adjustable. Several struts and shocks are offered in single and double adjustable options. Most of the shocks you'll find for the cars we race are offered in single adjustable. And for this Coney here, that single adjustment is via an adjuster in the top of the shaft. Most single adjustable shocks are rebound adjustable only, and that only adjusts your slow speed rebound, which is the rebound that you feel during most braking, cornering, and acceleration events. These adjustments can also be changed by the manufacturer of the shock by sending it back in and getting it revalved to give you more or less adjustment range if you find yourself at the extremes of either full stiff or full soft and you want more. Double adjustable dampers will generally be slow speed compression and slow speed rebound adjustable, and oftentimes you'll find the second adjuster on the bottom of the damper. An important consideration if you're looking at adjustable dampers is that adjustable dampers will cost you points under our current rule structure. Revalving a damper that fits under the 2X rule will not, and using a shock from another car that fits under the 2X rule will not cost you points either. Well, I hope this has helped you learn more about how to use your shocks on your ChampCar. Please make sure you hit the like button and subscribe. Leave comments here if you'd like for us to answer anything in the future. And thanks for watching.